All right. So today I'll be talking about Ethereum noise, right? Hopefully I'm pronouncing it right. So when you're making a transaction on Ethereum chain, there's something that is also part of a transaction, which is so-called noise. Well, noise, gas price, where you're sending it to, and the value of a transaction, data, we could be like, code execution or, just basically data payload, right? And this. But what we're going to be talking about today is just noise. Like, what does it represent, right? And as you can see from this block, it simply says that how many confirmed transactions these accounts are sent previously. So let's say you have your MetaMask wallet, right? You send like, two or three transactions before, noise is going to represent that. Now, the question is that why do we need to have that? Why do we need to know, right, number of transactions that you sent before? Now, this I like this particular content because it gave a very good explanation of why you need to have that, right? So in this case, let's say you are trying to send two transactions from your wallet, right? And and you're sending like about you have about let's say you have 24 Ethereum, you're trying to send well, you probably need to have need more than that for for gas. But let's say you're about to send like about 24 Ethereum from your wallet, you want to send 10 first and 14, right? So previously, I don't know, let's say previously you've not sent any before. So the first one that you send is a 10 and the second one that you send is the 14. Now the first one is going to have a noise of 0 because of course you've not sent anything before, right? So nothing has been sent before. Now after you send the first transaction, right? Now the second one is going to have a noise of what? 1, right? Now, yeah. So basically when it enters into the pool, it needs to be mined, right? Into the blocks. It the first one needs to be mined first, the 10 that you sent, right? So that noise represent the order that the transaction should be mined, right? You know, which is, which makes sense, right? Which perfectly makes sense, right? And so that's what we use the noise for, like in Ethereum transaction, just to sequence the order of transaction processing. And also they give very good, like also valid point here, which is the replay of attacks, right? Let's say you're trying to basically, you're trying to process a transaction. In this case, you are swapping Ethereum 10 Ethereum for 2000 DAI, which is when Ethereum was 2000 was 200. Right now, Ethereum is 2007 something. So yeah, so this is like a long time ago. I can see 2019, right? So uh, so you're trying to send, in this case, you're trying to send like a swap 10 Ethereum for like 20 DAI, right? Your transaction, you've done all those kind of things, right? Now the problem is that after you send a transaction, someone can grab a transaction and try to like replay the same thing. You try to replay, try to like replay the same transaction on the chain. But by trying to do that, it's going to get rejected because the miners are going to be like, oh yeah, there's a duplicate. Someone already did this, or there's a duplicate transaction, right? Because of the noise, right? So that's how it happens. Now, there are a couple of issues with noise, which was highlighted here, which is that, let's say you have multiple wallets, who is managing accounts. As you know, you can have like, your account in different wallets, the same account in different wallet. Let's say you are that kind of person that is doing that. Now, the problem is that um, both both wallets are going to be having different noise because most of these wallets have a way to actually manage your noise, right? Number of previous transactions. So both wallets are going to be seeing different noise, which is going to be an issue for you. Is going to be an issue for you. Let me give you an example, right? So let's say you have the same account being managing, being tracking two different wallets. You send a transaction from wallet A, the noise is what? 8, right? So therefore, the noise was 8. You send another transaction, the new noise, the next transaction should register a noise of 9. Now remember, the other wallet is not tracking the noise. So it's going to, it might register like a different value from uh, 9, right? Because it doesn't know there's a transaction that has been processed from a different wallet. So those kind of things could be like an issue when you're tracking, the same account in different wallets. Yeah, I mean, and also gap in noises, right? Because wallet A appropriately says the noise is 8, right? Then send out the transaction. Wallet B is supposed to be like, hey, the noise is what? 9, right? Because so that it can also get processed after the transaction from A. Now the problem is that if wallet B says something like the noise is 10, right, instead of 9, right, the problem is going to be there's a void. The last block noise was 8, and you are telling me the noise is 10. So there's a missing noise. There's a missing transaction here that needs to be filled, which is the 9. So there's going to be like your transaction is going to be pending until that particular 9 void is filled. Yeah. So you gotta be careful about that. Now, one thing I'm going to look next is that because I'm also like starts to pick up some of these things. I'm going to look like how the people solve like the problem of noise void, like in Ethereum blockchain. So hopefully this has been very useful. I'm going to include a link to the blog in this video. Yeah, that's it. All right.